Yeah, good evening all. Everyone can hear me? Online students, is my voice is loud and clear? Done. Okay, guys. So let's start the session. So in the last class, we are discussing about the machine learning. What is meant by machine learning? Where we are able to explicitly program means nothing but we are going to identify the relation between the input and output. If there is an output variable, then it is called as labeled data set. If there is no output variable, then it is called as unlabeled data set. Now, for unlabeled data set, we are going to apply unsupervised machine learning. For labeled data, we are going to apply supervised machine learning. That things we had discussed in the last class. Now, here, what is the machine learning means? Machine learning means nothing but identifying the relation between input and output. Okay, sir, machine learning means identifying input and output. This is for supervised machine learning. For unsupervised machine learning, there is no output variable now. For unsupervised machine learning, there is no output variable miss. Then what is it is going to do miss? It will identify the pattern, hidden patterns. It will identify the hidden patterns between them. And based on that, it is going to give the output. Miss, for example, let us see with multiple examples, not with one or two examples. We'll see the multiple examples. So finally, the machine learning is, it will identify the pattern. Whatever the data you have given, it will identify the pattern inside the data, and from that it will give the output. Okay, so that is called as machine learning. Now, coming to the machine learning, where the machine learns the data, it understands the data. Whatever the data you have given, it will understand. And based on that, it will work. Now here, we are having within the machine learning, we are having two types. One is called as supervised machine learning, and the second one is called as unsupervised machine learning. As I have told you earlier, machine learning is of two types. Machine learning is of two types. One is called as supervised machine learning, and second one is called as unsupervised machine learning. Supervised means if you are applying on a labeled data, if you apply on the labeled data, ML applying on label data, applied on ML, applied on label data, then it is called as supervised machine learning. If you are applying on the unlabeled data, the ML techniques which you are having, you are applying on the unlabeled data means, then it is called as unsupervised, right? Now, coming to the supervised machine learning and machine learning. Now here, in the supervised machine learning, we are having the examples are called regression and classification. These are the two techniques. Technique number one is called as regression. Technique number two is called as classification. Now, regression. What is meant by regression means? So as I've told you earlier, supervised machine learning is applied on the label data. What is meant by label data? Where output variable is available. Since output variable is available, output is available. What output? Output variable. Output variable is available. Now, since output variable is available, now this output variable can be continuous or discrete. If the output variable is continuous, then it is said to be a regression project. If it is output is a discrete variable, then it is called as classification. Okay, since output variable is available, now that output variable, if the output variable is continuous, it is called as regression. If the output is discrete means it is called as classification. As we have discussed in the cross-sectional data, we are having either continuous or discrete. Now, if it is continuous, output variable is continuous means output. Forget about the input. Input can be anything. No worries about the input. Only the output. Output is continuous means regression. Output is discrete means classification. Now, so whereas regression, what is meant by regression means? Now, regression. Just a minute. Regression means you are predicting the variable which is continuous. You are predicting a variable which is continuous is called as regression. Example of regression related problems. Predicting the mileage of a car, predicting the house price, predicting in terms of like a car price, used car price. Okay. Predicting in terms of house price, car price, sales, insurance, right? Insurance price, all these things, data scientist salaries, whichever is continuous variable is there, everything, whatever you are predicting the continuous variable, then it comes under regression related projects. Classification means where the output variable is discrete and you are predicting the output variable. Now, in the classification, what is the example means whether this person will buy the insurance or not buy the insurance, yes or no. Whether this person will get a job or not, yes or no. Whether this person will get a any kind of health disease, yes or no. Whether this person is already having the heart stroke or no. All this comes under classification. Okay. If you are predicting, so here simply to say, if you are predicting the output variable which is continuous. Okay. If anyone asks you what is regression means, regression. What is regression? Regression means predicting output variable, which is continuous. You are predicting the output variable which is continuous. Example, used car price. Car price will be a continuous. Since car price is a continuous variable, we are predicting the car price. House price. This is also house price, car price, mileage of a car. You are predicting the mileage of a car, or which is continuous, anything like insurance value, any value, some value should be there, right? These are all examples of regression. Now, second one we are having is called as classification. Next one is classification. This is regression, and the next one is called as classification. Now, what is classification? Classification means where you are predicting the output variable, same to same, above, predicting the output variable which is discrete, the output which is discrete. Examples are yes or no, whether the person will have whether the person will buy the insurance or not buy the insurance, all right? Whether the person belongs to this category or this category, X category or Y category, whether the person will join the course or not join the course. All these examples are classification project, whether the person will leave the company or not. Okay, so multiple projects are there. I'll show you with examples. And within this classification, again, it is furtherly divided. The classification is furtherly divided into two. The classification is furtherly divided into two. One is called as binary classification. Second one is called as multi-class classification. Binary classification means in the output variable, you are having only two categories. Okay, if the output variable consists of only two categories, then it is called as, so I'm writing in the top, I'm just erasing this one. Okay, binary, what is meant by binary classification? Binary classification means if output variable has only two categories, and we have to predict whether the person belongs to either this category or this category. If the output variable has only two categories, then it is called as binary classification problem. If the output variable has more than two categories, then it is called as multi-class. Okay, this is called as multi-class. multi-class classification. Heading as multi-class classification. So multi-class classification means output variable is having more than 2 categories is called as multi-class classification. If the output variable is having exactly 2 categories means it is called as binary classification. If the output variable having continuous, no classes are there, no categories are there, nothing is there, then continuous is there, then it is called as regression, right? So this now what we are going to do is just let us take one example for this. Let us understand with one example. You are having a data set. One data set is there. Just give me a minute. So here we are having a data set. See, engine size, cylinder, fuel consumption, and CO2 emissions. We are going to predict the CO2 emissions. The project, sir, how to identify the output variable? The first question is how to identify the output variable. How to identify output variable in the given data set. How to identify output variable in the data set? Answer is very simple. Your project is output variable. What you want to predict, that is the output variable. Which variable you want to predict, which variable you want to predict, that particular variable is output variable. Which variable you want to predict, that is output variable. Simple. So now, if you observe this one, in this data set, they have given the engine size, cylinders, fuel consumption, and CO2. 4 columns are there. 4 column names are there. Out of these 4 columns, which is the output variable, means first understand the business problem. What is your project? Your project is predict the CO2 emissions of a new car. That is the question. Predict the CO2 emissions of a new car. Okay. Now, then what we are having, which one we are going to predict? CO2 emissions. So CO2 emissions we are predicting. So this is the output variable, and output variable is represented by Y. The output variable is represented by Y. And these are input variables 1, X1, X2, X3. Input variables are represented by X. Output variable is represented by Y, and input variables are represented with X. Now here, if you observe, I'm having a data set. In this data set, total 10 records are there, where the index starts from 0, index ends with 9. Total 10 records are there. Now in this 10 records, the 10th record, whatever the 10th record is there, this I want to predict the answer. This is no answer is not there. This we have to predict. How we are going to predict means first we'll identify the relation by observing these 9 records. These 9 records, whatever we are going to observe, this is called as past data. Past data means on which we are going to start analysis. This is already completed. This is for the previous cars. For the previous cars, which is having the engine size and number of cylinders and fuel consumption, and the CO2 is this one. This is for the previous cars. Now, this is the future data. Based on the past data, we are predicting the future data. For example, now in this class, I'm going to say for a particular student, okay, you will get the job. If I say like this, how I'm saying that one? How I'm saying that one? Based on the past data, whatever the data I have observed in the market, so which type of students are getting the job, which type of students are not getting the job, and whether this knowledge is sufficient or not, based on that. So whatever the past data, the previous students, whatever my previous students are there, or in my company, whatever I have observed, these all observations are called as my past data. Whatever I have observed, my observation is called as analysis. Okay. Based on that, I'm predicting whether the person will get a job or not. Right. So here, whatever the data was there, this past data, based on the past data, first I'll analyze the past data. Based on the past data, first I'll identify the relation between output versus input. What is the relation? And once I identify the relation, based on that, I'm going to predict on the future data, not only for this car, any car. First, we have identified the relation. After identify the relation, we are going to predict. Right? Now, where if you observe here, this output variable consists of continuous variable. Continuous variable. Since it is a continuous variable, I'm using the regression. So regression is the process of predicting the continuous variable. Okay, predicting the output variable which is continuous, simply to say. Now coming to the next one called as classification. Now in the classification, if you observe here, I'm having there is a cancer data set, or with respect this one, benign and malignant, means whether the person will get a cancer or not. Okay, so benign means no cancer, malignant means there is a cancer cell in the body, there is a cancer cell. So now first you observe this one here, all the data is having the output is already there, means whatever the data set they have got, means patient records. Some people has got cancer and some people has not got this cancer after the test. Now any person with new data, I'm having a new data, completely a new data is there. For this new data, whether the person will get a cancer or not, I have to predict. What you have to predict? Either yes or no. Means either you have to say benign or malignant. You can't say the third one. Sir, 50-50, sir, 60-40, like this, nothing will be available. Either this or this, any one. In the output variable, any one you have to select. Okay. Now, for example, in the output variable, I'm having 3 categories. In the key 3 categories, output variable consists of 3 categories: X, Y, Z. Something you are having 3 categories, output variable. Now you have to predict either X, you have to predict either Y, you have to predict either Z. You can't predict a new one. You can't predict with a new one. Only either X or Y or Z. So for example, based on the previous patients, okay, for certain patients, we have given the drug X. For certain patients, we have given the drug Y. For certain patients, they have given the drug Z earlier. A particular hospital, a particular doctor has given for certain patients X, drug X, for certain people drug Y, for certain people drug Z. Now, if a new patient come and he is having these other symptoms, okay, input. For this input, what the doctor is going to predict means either X or Y or Z. You have to say out of these 3 only. You can't say, sir, drug E, a new one. Okay, within the whatever the categories are available within the data, past data, within the past data, based on this, we have to analyze and we have to predict. Right? So if the output variable is having a fixed categories, out of these only you have to select fixed categories are there, then it is called as classification project. Fixed categories are there means that is nothing but categories. Wherever the categories are there, it is a classification project. If there is no fixed values, anything can be there. For example, here you can predict 244, you can predict 245, you can predict 246. Anything can be predicted. You can predict even 940 also. Anything you can predict. You have to, they will not give certain categories. Within this category, select one. They are not asking like that. Right? So this is a regression and this is classification. Is that clear? The difference between regression versus classification. So if you are having the output variable, which is discrete variable, then it is called as classification. If the output variable is continuous, then it is called as a regression. Classification and regression comes under supervised. Right? Now coming to the unsupervised. The next concept is called as unsupervised. Now what is meant by unsupervised machine learning? As I have told you earlier, unsupervised. Unsupervised means you are going to apply the machine learning on a unlabeled data. Unlabeled data means there is no output variable. Sir, there is no output variable means then how we are going to work? Right? Now, very simple. For example, let us take with an example. You'll understand unsupervised machine learning easily. Every day we are using the YouTube. Everyone are using YouTube every day. Okay. Now in the YouTube, you are watching one video. Certain video you are watching, whatever the video it is. You are watching one video. Once you have watched this video, you are watching one more video, second video. Okay. And you are going to click on the third video. 3 videos you have watched. After watching 3 videos, now YouTube is going to recommend you some videos. It is going to recommend you some videos. This recommended videos, what is this recommended videos? Miss whatever you have watched in the previously. Based on that, it is going to recommend. For example, you have watched first one is some movie related some movie. Okay, related to something jokes. One more video related to jokes. Okay, something related to third video you have watched something related to some cricket. Okay, something you have watched like this. Now, based on this only, it is going to recommend. Why it will recommend you some kind of international politics, or whether it is going to recommend you blockchain technology. What is meant by blockchain technology? Whether it is going to recommend you any IoT, or whether it is going to recommend you any mechanical engineering. Nothing it is going to recommend. Why it is not recommending? Because you have not worked on that. You have not opened that, related that videos. If you have clicked on the YouTube, something kind of what is meant by blockchain technology. In the search button, you have typed like this: what is meant by blockchain technology? You have got certain videos. Out of certain videos, 1 or 2 videos you have watched. Okay, they will understand that this person is interested towards the blockchain technology, and which is the most viewed blockchain technology video is there, that it is going to recommend for us. Right? And that too, you are watching the every video maximum of 3 minutes, 4 minutes only. It is going to recommend for you also 3 to 4 minutes video only. It will not recommend you 3 hours or 4 hours video, because anyways, you are not going to see that one. If it recommends also 3 hours video, you will not see that one. Simply, you'll ignore that one. It will just recommend you only 3 minutes, 4 minutes or 5 minutes videos. For example, if I click on my YouTube now, if I open my youtube.com, now immediately I will get in the front page some videos. First page, some videos will be there. What those videos are based on my past history, whatever I have observed. Right? Whatever the things we have seen earlier, based on that, it is going to show us. Right? Now, this entire thing, what is it is going to recommend? It entirely depend on your past data. Based on your past data, it is identifying your interest, which area you are interested. And based on that, it is going to recommend the movie. This is ML project. Entire YouTube is an ML project. Complete YouTube, okay, is an ML. Just based on your previous past history. For example, let us, just now you created a new mail. Some mail you have created just now. First time you are creating a new one. Right? You have created a new mail, and first time you are clicking on the YouTube channel. Any YouTube video, you are just clicking for the first time. First video you are clicking, you will never get the ad. You will not even get the ad. For example, this video is related to some movie clip. In that movie, PK is there. Some hero PK is there, and you are watching that PK video, something completed. Movie clip was completed. That is 5 minutes video. Okay. In this 5 minutes, whether fighting scene will be there, or comedy scene, or some kind of action, or I mean, in terms of drama or something will be there. It will identify even that one also. For example, let us assume it is having some drama. Okay. Second one. Second clip I have watched. In this, again, same PK hero is there. Again, drama is there. But different movie. Movie name is different. Now, again, I have watched one more movie clip, PK, and some more drama. It will understand. SRK is more interested. PK. He's a PK fan. Machine will understand. Now, when I click on the fourth video, it will play the skip ad. I'll wait. I will click on the skip ad and I'll watch the video also. Okay. If I give the skip ad also, this person is skipping, and finally he's watching the video. Next video without skip ad. Now again, I'll watch the video. I will wait for once the ad is getting completed, I will wait like that. Once the ad is completed, I will start watching the video. Okay. Then though we give one ad also, he's watching. He's fully dedicated that one. Means full of passion. Interest is there. This time two ads. Increase the level of ad. So like that, whichever you are interested, for that only you'll get the ads. Whichever you are not interested, you'll not get the ads. First time if you are watching, for example, I don't know Hindi. Generally, I will not use the Hindi. I will not check in the YouTube Hindi also related. Hindi video, nothing, none of the video I'll watch. Right? Suddenly, I have watched it for the first time. Hindi news channel. I have clicked on the Hindi news channel. I will not even get the one ad also. But the same thing, if I watch any movie clip, immediately I will get the ad because the YouTube knows that I'm interested in the movies in the YouTube. Immediately it will give. Example only, guys. I'm not interested. Example only, pure example. Okay. Anyways, already I have got edited towards the YouTube and I have paid the subscription also. Premium account also I have done. Because on continuation, it is giving the ads only. Because it already, number of videos, I have played the number of videos, not with one or two. Multiple videos I have played. So multiple videos, when I have given the more data, it will understand about me very clearly. It will understand completely about me. The more the data I give, the more understanding it will do. So once I got edited towards the YouTube, 100% I have to go with the premium account. There is no other option for me. Otherwise, ads I have to see. I have to spend my entire time on the ads. So now what happened? I got edited towards the YouTube. Okay. Now this, once I have edited towards the YouTube, when I have done, it has collected the data. It has completely collected the data. Whatever the data I'm interested previously, it has collected complete data. So this is completely of unsupervised machine learning, and which is the part of recommendation engines. Similarly, Netflix, similarly, Amazon Prime, similarly, Disney Plus Hotstar. In the Disney Plus Hotstar, if you open, first initially you'll get with respect to something. And once it is completed, based on previous your watch, I'm recommending this one. If I open my Netflix account now, in that Netflix account, what it is going to show based on your past history, past viewed, based on that. Now, generally, if a video, it will show some video, and this video I'm interested or not. How the YouTube knows that one? Whether it is asking any rating? No, it will not ask the rating, but still YouTube understands how much I'm interested in that video. How it will understand, you know? So total video length is of 4 minutes, 20 seconds. Assume. Okay. Out of these 4 minutes, 20 seconds, how much is my viewing time? If 4 minutes, 20 seconds I'm viewing, miss, obviously I will be interested. If I'm not interested, why will I watch that much time? If you're not interested in any particular, for example, 2.5 hours movie is there. This is not cinema theater na, to sit continuously there only. 2.5 hours movie is there. Assume something is there in the YouTube. 2.5 hours movie is there. If you're not interested, what we'll do? Skip, and we'll move on, right? We'll drag off. But every second, 2.5 hours movie miss, total 150 minutes. Every minute, every second you are watching continuously. What is that meaning is? You are completely interested. In that way, it will identify. Now, whichever the movie you have watched till miss, maximum time, whichever the clips or whichever the movies or whichever the things you have watched, whichever the videos you have watched, based on that, it will identify which is your more interest area. In that way, it will identify the more interested area. And based on that more interested area, it is going to recommend us. Now, whatever we type in the Google, now since earlier YouTube is by a different company, but Google has acquired the YouTube some long time back, right? Now YouTube is the part of the Google only. Now Google, in the Google search engine, I'm typing something. I'm trying to find something. Now this Google, whatever I'm typing in the search engine, that is also integrated with the YouTube. Whatever I'm typing in the YouTube, it is getting connected to the search engine. Search engine, what I'm typing, it is getting the YouTube. In the Google, I'm typing in terms of data science. Data science, something I'm typing like this. Immediately in the YouTube, I will get one ad with respect to upgrade. Okay, whoever types in the Google data science only, they will get that ad. If you don't type in the Google data science, you will not get that ad. Okay, if you are having 2 or 3 accounts, try. First, what you have to do is in your system, completely clear the Google history first. Clear off entire Google history. Whatever in the Google you have typed, everything clear off first. Go to the settings and clear the history. Okay. Once you have cleared the history and create a new mail ID. Don't use the same mail ID. If you use the same mail ID, already past history was loaded now. Don't use the same mail ID. Create a new mail ID. Once you create a new mail ID, now you go into the YouTube. Now automatically, earlier, whatever the videos you have watched, again try to watch. Now the ads will be different. Some videos will not have the ads also. Now, whether which video you'll get an ad, which video you will not get the ad also, I'll tell you. If you give me your history, I will tell the for which video you'll get the ad, for which video you'll not get the ad. Okay, based on your YouTube history. That too, not with respect to 1 year back history, last 1 week history only. I'll not take 1 year's back history. 1 year back, I'm interested in Modi. I'm not interested now. 1 year back, I'm interested in something. I'm not interested now. Even yesterday also, I'm interested. Today, I'm not interested. What we can do? My interest has changed today suddenly. That one also YouTube will identify. How it will identify, miss? There is a concept. I will explain. That is only algorithm. Right? That algorithm works on that way. So these all the things irrespective of output variable. There is no output variable for this. You are not going to predict anything. Just based on your data, it is identifying the patterns. So the recommendation engines is the part of the machine learning. So here, if you observe here, this is a clustering. Clustering means grouping of similar data. Okay, you are going to group the similar data. That is called as clustering. So this clustering technique, to understand the clustering, very easy way, go to the COVID 1.0. COVID has given us multiple examples. Okay, COVID example is very easy to understand. Right? COVID first one, that is March 2020. In the year of March 2020, where we are having the first lockdown. Right? At that time, we are having in terms of areas like red zone, green zone, and orange zone. They have divided every particular city, town, village, everything into the red zone, green zone, and orange zone. Each one is a cluster. Each of them is a cluster. Cluster means they have grouped the similar. Wherever the similarities are there, they have grouped them into one. Whichever is having the similarity of orange zone, they have grouped into one. Wherever the green zone similarities are there, they have grouped into one. Now, why have they have grouped like that? So that the administration work will be easy. The collectors work or joint collectors work, their work will be easy. Means they will try to more focus on the red zone areas. They will try to give with respect more medical equipment into that particular areas. First, they have to identify the areas because we are having with respect to limited number of stock. When we having the limited number of stock and we want to distribute to the needy people, first we have to identify the needy people. Who are the needy? For identifying that, they have divided the entire data like this. This part is called as clustering. Okay. And even Modi in his speech and even in even chief ministers also in their speech, they'll say that this particular cluster zone, if you follow their speech, they'll say that cluster. The word called as cluster. Cluster means group of similar objects. A group of similar objects is called as one cluster. Just they are one group. Sir, we four of them are close friends, sir. We four of them are very close. They are one group. They are one cluster. Those four friends are one cluster. Right? Group of friends are one cluster. Every group is one cluster. Now, so for example, in this class, total 40 students are there. Assume 40 or 20 or 30, whatever it is. Some X student. This X student is there. Okay, he is making the friendship with this Y student. Assume. Okay, some friendship with the Y student. Why he is making only friendship with that Y student only? Why he is not making the friendship with another student? Why that particular student only? Similarity. Just a similarity. Whatever this person is discussing and he is something discussing and this person also discussing, both of them are matching something. Wavelength is matching, means they feel that they are friends. If their wavelength is not matching, they will not feel as the friends. Okay, suddenly a new person comes into this class. He will come and sit in the side. Arey, hi Ram, miss. This person also says, hi, how are you? And like this, they discuss, miss. Next day, they will become friends. Hi, miss. Hi. Okay, let's wait. If we say like this, next day, this person will speak once again. Simple logic now. This conversation also recommendation part of the clustering. This conversation also will be converted to numerical data and we'll analyze. This one also will analyze. How the person behavior pattern is there also will analyze. Every minute thing we can analyze. If you want to analyze means we can analyze. If you want to ignore means we can remove. Simple. In this class, few students are there. Every day they will come and they will sit and they will write something. Everything what I am observing with my eyes, everything I am analyzing. Every minute detail I will analyze. If I feel that it is not important means I will delete from my brain. If I feel that it is important means I'll analyze. I'll keep that one. Right? Now, with respect to this is called as clustering. Clustering means just grouping of similar objects. There is no output variable, just clustering. Next, association. One of most important for the DMart, Reliance Mart, for all these things. Supermarkets. For all the supermarkets, it is going to be a mode. Only for supermarkets. This is also called as market basket analysis, MBA. Not Master of Business Administration, market basket analysis. Market basket. Basket means whatever the basket of items you are going to purchase. Okay. So market basket analysis. So for example, we are having something called paste is there, Colgate paste. For Colgate paste, I want to increase the sales. For this, I want to add some kind of combo offer. Why I'm adding only the brush only for this paste? I can add even anything also now. Why I have to add only brush? Because generally we know that along with the paste, generally we'll purchase is brush commonly. Right? Which is the best combination for the cool drink? If I select the cool drink, I want to purchase anything additionally along with the cool drink. What is the best combination? Chips only, right? Whether it is a Lay's packet or whether it is a bingo or something, whatever it is, that is secondary. But chips, that is common, right? Everyone knows. Now, for example, if you want to give a combo, chips, what is chips means? It is the most repeated. Many of the people, sir, along with the cool drink, I will purchase the milk, sir. I'm interested in milk. You are a special one. Okay, for special one, special offers we can't create, right? For most of the repeated one, who are having the repetition, commonly repeated one, for those people, we are going to identify the offers, right? So what it is going to do means just apply the mode concept. Mode means most repeated one. It will apply the most repeated one, and based on the most repeated one, and from that it will identify the patterns. So association, frequent co-occurring items. Co-occurring means both of them commonly occurring every time. Frequently, most frequently, repeating the same thing, getting repeated every time. Right? Now, next one we are having is called as anomaly detection. In the machine learning, next one is called as anomaly detection. Now, what is anomaly detection means? Anomalies, something different will be there. Okay, in the class, every person will be one type, one person only will be different type. He is called as anomaly. Sir, anomaly is also simply to be more simplified for you. It is an outlier as of now. Clearly, we'll discuss during the classes, but as of now, which is an abnormal data. It is called as anomalies, abnormal data. Right? Now, sequence mining. Next one is sequence mining. Sequence means for sequential data, means for time series data, we are going to apply this. Whatever we are having till now, everything are applied for the cross-sectional data. Only sequential mining is applied for the time series data. For time series data, we are going to apply the sequential mining in the sequential order. The sequential order is important for us. Here, the sequence is more important. Okay. And the next one is dimension reduction. Dimension reduction means you are going to reduce the number of input variables. As I've told you earlier in the yesterday's class, the basic introduction, dimension reduction means just identifying the unimportant variables and removing them. This is called as dimension reduction. Next one is called as recommendation systems, where earlier, again, I have told you that YouTube, Netflix, all this works on the recommendation engines. Again, they'll identify your past history. How the Netflix will recommend you? or Amazon Prime will recommend you the movies miss based on your past history. If I open my Amazon Prime account now, it will show some movies which are related to Telugu only. Why it will show for me Hindi movies? I have not even watched one Hindi movie also in the Amazon Prime. Why it will recommend for me? It will identify within that Telugu movies only. Though the Hindi movies super extraordinary hit also, it will not even recommend me because I have not even watched one movie also related to Hindi or related to Urdu or related to German. None of the language apart from Telugu and English, nothing I have watched. So it might be if I open my Netflix means it will show only the web series. It will recommend me web series. In the Netflix, I'll watch only web series. If I want to watch any movies miss, I'll watch in the Amazon Prime. If I want to watch any cricket matches or something miss, I'll open the Disney Plus Hotstar. Right? Nowadays, OTT platforms are there. Multiple OTTs are there. So we are going to open all of them. If anything special miss, like something as per our requirement, whatever the OTT we are interested. Every OTT platform is backend is recommendation engine only. Any OTT. Select whatever the OTT platform you are interested. Everything is recommendation engine, including your YouTube. Right? Now, so these are the various applications of machine learning techniques. These are the various machine learning techniques. Every technique we are going to see one by one. In the next 1 month, we'll see all the techniques. Each and every technique we'll see. Association rules, recommendation engines, dimension reduction, all these things, everything. Right? Is that clear, guys? This is the basic intro only. Very detailedly, we are going to discuss in the further classes. Now, as I have told you earlier, supervised and unsupervised classification and regression comes under supervised. Clustering and recommendation engines, all this comes under unsupervised, where there is no output variable. So this is working on the labeled data. Unsupervised will work on the unlabeled data. Right? Done. Now, classification. As I have told you, the classification where we are having the output variable is number of classes, and we are going to predict either of this. And regression, where we are predicting the continuous variable. Based on the past data analysis, we are going to predict the continuous variable. Next one is called as clustering. Clustering means just grouping of similar objects is called as clustering. And now for this, we are going to use the multiple Python libraries. Out of multiple Python libraries, the first one is pandas. For loading the data or for giving the input data or output data. For example, in the given input data, this is the entire input data where I'm having 20 columns. Out of 20 columns, 19 of them are input and one is only output. That output variable I have to separate. How to extract the single column? df of that particular single column, we are going to extract like this. See, whatever the column name. We are going to write like this, the column name. This is the way we are going to extract the single column. Now in this entire data, 19 input columns I have to take. One only I have to drop. Now what I'm going to do, whatever the output variable is there, that I'm going to drop. How to drop the output variable? df dot drop. You are going to use df dot drop and you are going to take the output variable, whichever the output variable is there, and axis is equal to 1. After dropping, you are going to get a new data frame, and this new data frame you are going to take as x. What is your y? Which is nothing but your output variable. Simply, this is fixed every time. Every time it is fixed. X means dropping the output variable and remaining everything is input. Whatever the output variable is, that is the final one. This is the output variable. Whether you are having 400 columns also, the logic is simple, just 2 lines. Whether it's 500 columns also, the 2 lines, same to same. Just we are dropping the output variable and remaining everything is input, and whatever the output is there, that particular column is the y, x and y. Right? Now this everything, drop function and selecting a single column, everything we are going to use using the pandas, completely pandas. Now sklearn. Sklearn means scikit-learn. Sklearn full form is scikit-learn. In shortcut, we used to call as sklearn. Sklearn. The full form is sk means S stands for sci, K stands for kit. Learn. Scikit-learn. Now, what is meant by sci means scientific. S stands for scientific. Scientific kit. Scientific kit learning. Scientific kit learning. Basically, sklearn means scientific kit learning. Okay. So some people will say that scikit-learn, or some people will say sklearn. You can use sklearn, scikit-learn, or scientific kit learning. If you say scientific kit learning, everyone will see like this. Hey, what you are saying? Everyone knows, don't full form na. Just they know what is scikit, what is meant by sklearn. Only these two everyone knows, right? So scikit-learn or sklearn. Next NumPy. Next one is SciPy. Next one is Matplotlib. So earlier we have worked on the NumPy, Pandas, and SciPy. We have seen how to use the SciPy in the hypothesis testing, right? And next Matplotlib, we have seen the Matplotlib and Seaborn. Scikit-learn. Now we are going to work every algorithm. Every machine learning algorithm is the part of the scikit-learn library on. Everything, including recommendation engines, including the association rules, including the time series, including everything. Everything are the part of the sklearn, right? Now, so scikit-learn is a library that consists of many machine learning algorithms. It utilizes a general framework where we are having the APIs. APIs means we are going to import that one and we have to fit. We are using the fit now. Wherever you are using the fit means API. Basically, it is an API. So what is the difference? For example, defer add function a comma b, return a plus b. This is a simple function. Okay. Now I'm going to use this function add 2 comma 3 and it is going to give me the output called as 5. Okay. This is a simple one. Now, sir, this is a simple one where we are calling the function. Now, what is the difference of add dot fit of 2 comma 3? What is add of 2 comma 3? What is add dot fit of 2 comma 3? Means here also it is going to take a is equal to 2, b is equal to 3, and it is going to execute the entire code, whatever is there inside the function, it is going to execute. Here also it is going to execute. But this is called as function, whereas here the add is called as API. For APIs, we have to do the fit. Fit means then it is going to fit by selecting the A is equal to 2, by selecting B is equal to 3. Same to same. How the function will work, same. But certain things we are going to create by using the functions, certain we are going to create by using the APIs. In the sklearn, everything is an API. The library was designed like that. The library was designed like that. So that is the reason wherever we are using the sklearn dot pre-processing import one hot encoder dot fit we are applying. If you are taking that min-max scaler dot fit we are applying. If you are taking the standard scaler dot fit we are applying. Whatever we are importing from sklearn, for everything we have to use the fit only, because sklearn was an API. The library was designed in that way. It is a library. It is not the module. Whereas NumPy is a module. Pandas is a module. They are functions. Directly they are functions. For the functions, you have to give only the input arguments. No need of fit. Okay. In the pandas dot drop means whatever the data frame, df dot drop. This is a function. Inside the function, we are going to provide the input arguments. Here we are not going to fit. Just directly we are providing the input arguments directly into the function only. But for whichever we are using for sklearn is an API. sklearn library is an API. For this API, we have to do the fit. So this means whatever the algorithms we are using, first we have to import and then we have to fit in order to use them. Import, fit, right? Next, sklearn also comes with many convenience tools, including the train test split, functions, cross validation, and variety of reporting metric functions. So this is one of the most important. Train test split, cross validation, and metric. So this having multiple things, data pre-processing is there, data evaluation is there, everything is there. So this is sklearn is also called as one-stop shop. Means everything is available in one location for entire machine learning. For all your machine learning in only in sklearn it is available. Okay. So now coming to the next one. So for any project, any ML project, for any ML related project or ML or DS related project, what is the difference between ML project versus DL project? ML project versus DL project. What is the difference? what is the difference between DS project versus ML project? ML project means purely we are going to apply ML algorithms only, nothing else we are going to apply. We have to apply the ML algorithms, and based on the ML algorithms, we have to evaluate the data, and finally we have to submit the report. What are the things? Only ML algorithms. For DS projects, we have to do some kind of data analytics, and in some situations, we have to even apply the artificial intelligence also. Okay, in ML, no artificial intelligence will come. Only ML will be there. ML project means only ML, nothing else will be there. Okay, now coming to this project, generally a project will consist of, as I've told you earlier, once again, I'm showing you this one. The most important, just I'll show with an image. Just give me a minute. So here I'm typing CRISP-DM methodology. Okay, now I'm just clicking on the images. So this is the CRISP-DM methodology. Any data science project is of 6 steps. The same thing I have explained multiple times in the early stages, but now it is important. Now here, business problem understanding. First step is you understand your business problem. Okay, take one example, and based on that example, you understand. So the example is in this PPT, whatever the previously we have got, let us take this example only. Okay, for this project, what is the business problem is estimate the CO2 emissions of a new car. Estimate the CO2 emissions of a new car with maximum accuracy, common. With maximum accuracy, what is common? For any project, maximum accuracy, we have to predict with maximum accuracy, right? So estimate the CO2 emissions of a new car. This is the project. Now, business problem understanding. I have understand my project. After that, what I have to do? Data understanding. In the data understanding, they have given me engine size. What is meant by engine size? I don't know what is that. Just check in the Google, and you have to do the research. Which are the variable name we don't know, we have to do the research. We have to check what is meant by engine size, what is meant by cylinders. Generally, a car will have how many cylinders? A normal shift car or a normal Benz car or any car, generally the cars will have how many cylinders? What is the impact of cylinders? If the cylinders are more means what happens? If the cylinders are less means what happens? Everything we have to understand first. Okay, and next fuel consumption. Fuel consumption underscore COMB. What is meant by COMB? Combustion. Fuel consumption, combustion. So it is combustion. Combustion means it is going to ignite. Means fuel and oxygen both will mix. We have to understand all these parameters. We have to check. Sir, I'm not from automobile background, sir. I'm not from mechanical background, sir. We can't say like this. This CS here, data science is not with respect to only CSC. Data science is a interdisciplinary. You have to apply mechanical, you have to apply automobile, you have to go with biotechnology, you have to go with biosciences, you have to go with HR, you have to go with manufacturing. Multiple domains we are going to apply. It is not with respect to only computer science. I know only computer science, sir. Instead of asking engine size, ask me what is meant by server. What is meant by website? Just ask me like this, sir. What is the web host? What is the difference between web host versus local host? I'm from CSE background, miss? No, it is not with respect to from CSE background. That is the difference between if any non-IT student wants to convert to IT industry, he can convert in data science, but he can't become as a full stack developer. For full stack developer, he has to be a CSE student only, not with mechanical or automobile or chemical engineering. Very less chances. But whereas in data science, there are more chances because we are going to work on the multiple projects, interdisciplinary projects, right? Now, here, first we'll understand the data understand. If you're not for your data, these variables are sufficient or it is not sufficient. For predicting your business problem, whatever the given data is sufficient or not. If it is not sufficient, you have to send that mail to the data engineering team that this particular data is missing. For predicting the CO2 emissions, apart from this one, this is one more data I require. So please collect the data. You are going to share the team. So they are going to work. They are going to collect the data, right? So if you are the data engineer, you only have to collect it, right? So once for the business problem, whether the given data is sufficient or not, just check and understand this one. See, double arrow mark is there. Double arrow mark means for your business problem, you have to come back and front. Okay, you have to cross verify. Once this is done, next you are going to do the data preparation. I already told you what is meant by data preparation. Data preparation or data pre-processing, both are same. Before sharing to the machine, what are the things you are going to do? That is EDA, data cleaning, data wrangling, and future selection. Which are important variables, which are unimportant variables. All these things called as data preparation. From this data preparation, you are going to share that entire data to the machine. Now the machine starts learning. And it will start the learning and it will predict the answer. Okay, for that, for example, let us take this example. I have given this one to my machine. My machine has learned. And I'm asking for this data, what is the answer? It will say that 240 is the answer. What is the accuracy? With what accuracy? 100% it is 240, yeah? Or what is the accuracy? Some accuracy will be there, right? That accuracy is called as evaluation. Your model, how your model is predicting is called as accuracy. You are going to check your accuracy. Accuracy is nothing but evaluation. You are evaluating your model. What is meant by model? Model means whatever you have designed, that is model. Whatever you have created, whatever the relation you have identified. For example, simple example, X and Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y is equal to X plus 5. This is called as model. This is called as model. And for this model, and for 6, it is predicting as 11. Answer as 11. Before predicting, first I want to check whether this model is a good model or not, whether this is a correct one or not. Just I want to cross verify whether it is having 100% accuracy, or for example, let us take here 19. Now you will not get 100% accuracy. That is also 100% sure. 100% sure that you will not get the 100% accuracy, right? So here you will not get the 100% accuracy. You'll get with the 80% or 85% or 90% accuracy will be there. And for 6 also, again, you are going to predict. For 6, you are going to predict, right? For 6, you are predicting whatever the value. This is also with 70% or 80%, whatever the accuracy, right? So this is called as evaluation. With what accuracy you are going to predict the answers. That is called as evaluation. Once you are evaluated your model and this evaluation is satisfying your business requirement. For example, I ask you to predict with 80% accuracy. Now, whatever you are going to do, whether this is giving 80% accuracy or not, right? So just you are comparing this one, whatever the accuracy or whatever the evaluation is there, this evaluation satisfies my business requirement or not. If it is satisfying the business requirement, then present to the client and submit. If it is not satisfying, means again start from the starting. Again start from the starting, right? Again do where is the mistake you have, where the mistake you have done, and identify that one, and you have to work. So this is called as data science life cycle. Life cycle means the entire project will be done within this only, right? So where we are going to do entire life cycle from starting to ending in the projects. Okay. So no need to worry. Everything is very simple, one by one, right? Whatever we have done earlier, between that only everything is there. Nothing new is there. Is that clear, guys? So by applying the life cycle and by using this libraries, coding is dead easy. In data science, the biggest advantage is coding. Coding is a very simple one. Only the concept we have to understand. Without understanding the concept, if you write the coding, then you are called as coding monkey. Okay. In the industry, they will call as coding monkey. And you can't even sustain also. 1 day, 2 days only you can sustain. If you ask someone, for 6, what is the answer? 11. How? Sir, why, sir? 11. 11, sir. Don't ask why. I'm saying answer na. You want answer. Answer is 11. You given the data is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, like this. You are asking for 6. What is the answer? 11. Don't ask me why. Your requirement is 11. Sorry, your required answer is 11. Right? So they'll say like this. They'll not tell the reason. They'll not tell us the reason why. Just they'll say that it is 11. Though it is a correct answer also, they'll not tell the reason. Means either two problems. One, they don't know how to explain that one. Though they are having the subject also, they don't know how to explain. Two, they have copied from somewhere. From somewhere they have copied. Or to someone they have asked the question and someone has already given the answer and he is giving the answer to me. These two reasons, might be two reasons. Out of these two reasons, generally in the industry, the second reason they'll consider. Instead of considering the first reason, that okay, this person is having the talent, inbuilt talent is there, but he don't know how to express himself. They'll not feel in this way. They'll assume that this person is a copied person. By default, they'll go with the second argument, second one only, second option. And they'll assume that you have copied from somewhere and next day they'll remove. Right? So you have to tell the reason also. What is the reason and how you have applied and what is the things. Is that clear, guys? So the coding is dead easy in the entire machine learning. Here, the most important thing is called as train test split, cross validation, and evaluation. These three of them. What is meant by train test split? The next concept is called as train test split. Train test split. Heading is train test split. One of the most important. Okay. And easy one. Okay. You will feel this one after 1 month. After 1 month, if I ask this one, you say that, sir, this is dead easy, sir. You say like this. Because why? The reason, you know, from tomorrow onwards, every day we'll use this one. Multiple times we use now. After multiple times, 1 time, 2 time, 3rd time, 4th time, multiple times we are going to revise, multiple times we are going to practice, multiple times it will be happen now. Obviously, it will be easy only. Which you are discussing only for 1 time only will be difficult. Which one will do the practice for multiple times, it will be easy. Okay. So, what is train test split? Train test split means your entire data. Whatever your entire data is there, the entire data is divided into 2 parts. Your entire data is divided into 2 parts. One is called as train. One is called as test. This is called as train test split meaning. The entire data is divided into 2 parts. How you are going to divide the entire data into 2 parts means randomly. So, for example, I'm having the 10 records with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Out of these 10 numbers, so total 10 numbers are there here. Out of these 10 numbers, I want 80% for training, 20% for testing. And I ask you to randomly choose 8 records from this. What you are going to do? You are going to choose 1, 3, 4, 5, 9, 7, 10. Something you are going to choose like this. Randomly. Randomly, any 8 records. Any 8 records. Any 8 records randomly. Any 2 records. 2 out of 10. Out of 10. Any 2 out of 10 randomly. Any 8 out of 10 we are going to choose. Any 8 of 10 we are going to choose here. Any 2 out of 10 we are going to choose here. Whatever we have chosen for training, we are not using for testing. Both are mutually exclusive. Which of the records are used for training, that record are not used for the testing purpose. Both are mutually exclusive. Right? So 80% of the data we are using for training, 20% of the record is used for testing. Sir, what is the meaning of this? Can you explain in a simple way? Let us take like this. Okay. Now, in the stock market, okay, let us take one stock market example. January 1st, 2023. The share value is this one. Let us open in front of you directly the values only. Just Here I'm typing one company name. The company name is called as TCS. Software company now. So TCS. Now this is a TCS graph, time series plot. This is a time series plot where I'm having the data from here to here. From starting of year of maybe around, if I keep, what is the starting date? The starting date is 5th May. 5th May 2022 to means 1 year data is there here. Almost 1 year data is there. Okay, from 5th May to this one. Now, this 1 year data, I'm going to give to my machine. And I will ask my machine to identify the pattern. Okay, it will identify the pattern. After identifying the pattern, my machine, I'm asking to predict what would be the tomorrow's graph, next 1 week's graph, next 1 week. Next 1 week, what would be the graph? Whether the graph is like this, or whether the graph is like this, or whether graph will be like this, something, whatever it is. Just I'm asking my machine to predict by observing this one. I have given the entire data to my machine and I asked my machine to predict. The machine has predicted the answer as something like this. It has predicted. Machine predicted means 100% will be a. If the machine gives 100% accurate results, I will not be in front of you. I will be in the stock market. Okay, I will be investing and I will take the profits and I will enjoy. Evening hours I'll enjoy, morning hours I'll invest. Right? I will not be in front of you. Right? The machine will not give 100% accuracy. That is very clear. Now, here, whatever the machine in terms of it is giving the this one to how much accuracy it is going to give means first this entire data I'm going to take for my mission from here to here only. I will share the mission only the from here to here only. I will give the data from here to here only. Now from here to here, first I'll ask my machine to understand this one. First you understand this one and you predict what happens next one. If my machine is able to predict like this, if it is my machine is predicting something like this, okay, which is almost close. If my machine is predicting like this, then this is already the answer I am having. Answer is already with me. I'm comparing whether my machine is properly it is working or not. Original answer is already with me. Original answer is already with me. I'm comparing whatever the machine predicted values with the original values. Comparing, you're comparing machine, whatever the machine predicted values, whatever the machine has predicted, some predicted values to your original values. Okay, between these two, predicted versus original. If the original value is 150 and machine is also predicting 150 means okay, 100% close. If the machine is predicting original value is 150 and machine has predicted 140 only, the difference is 10. I'm going to identify the error. Error is how much? The error is how much? That is 150 minus 140, which is 10. Like this, I'm going to calculate the error. Right? This calculation of error is called as evaluation. Calculating the error is evaluation. For doing the evaluation, first I have to know the original answer now. If I don't know original answer, how I can evaluate? First I have to know the original answer. First I have to know the original answer means, for example, what happens tomorrow? Tomorrow first I have to know now. For example, if I ask my machine, predict tomorrow's date is 6th. May 6th, what is the value of TCS means? It will predict some answer. It will predict. But whether it is a right answer or wrong answer and what is that? First, I have to know the original answer, right? I only don't know original answer. Then how I can say whether it is a correct answer or wrong answer? So for that reason, what I'm going to do, whatever the given data is there, this entire data I'm going to split into two parts. This part is used for training purpose. The machine will be trained only on this part and the same machine will be tested on the remaining part. Now in the remaining part, how the graph is there and based on the graph, I'm going to estimate how much it has evaluated correctly or wrongly. For example, my machine has predicted exactly 100% exactly is the same to same, no difference. As it is, it has predicted. Based on my machine, I will invest my entire money also. In the future, automatically it will say that it is going to increase means I will invest complete money. If it is predicting with low miss, I will exit from that particular company. If I'm having any some stock and I'm having some stocks miss, I'll exit from that company. right? So this evaluation, this is called as evaluation. You are evaluating the original answers with the predicted answers. So for doing the evaluation, we have to get the first original answers. So for getting the original answers, the entire data was split into two parts. Is that clear now? What is meant by train test split? Train test split followed by evaluation. Okay. You are going to split the entire data into two parts. And after that, you are going to evaluate how much your machine was predicting accurately. Is called as train test split and followed by evaluation. Now, okay, for time series data, since it is a sequential data, I have to give the entire data in the sequential order. I can't give the randomly. I can't give some records from here, some records from here. I can't give like that. For sequential data, we have to give the training data also sequential only. Okay, but for cross-sectional data, we are going to give the randomly some data points. For cross-sectional data, randomly we are going to choose. Example, let us take like this. Okay, here one more data set I'm having. In this data set, I want to predict for a new person, whether the new person is having the B or M, that is Penguin or Malignant. I want to predict for a new person, for a new data. Some values are there. For these values, I want to predict whether the answer is this one. First, I have to analyze this one. For analyzing this one, I'm going to split the data into two parts. Okay, randomly I have chosen this one, this one, this one, this one, this one, this one, this one. Like this, I have chosen randomly, not in the serial order. I have chosen randomly. Randomly, I have chosen, and I have got the accuracy as 90%. If I change the data, the accuracy also changes, right? Instead of collecting this data, I have got 90%. If I change the data, means answer also changes. If I change another data, means again new answer I will get. As the data changes, new answers I will get every time. Now, which is the final answer, then correct answer? Which random is correct answer? Means that is called as cross validation. Cross validation means you are going to cross validate by selecting the different data sets. By changing the data sets, how your machine is working or not, that you are going to see. That is called as cross validation. Now, what I am going to do is this entire data, whatever the entire data is there, assume this is 100% of the data. This 100% of the data, I'm going to divide into 5 equal parts. 5 equal parts. Out of 5 equal parts, now this is used for this first part. Assume that total 100 records are there. 100 records, I'm dividing into the 5. Means first one is, it will consist of 20 records, followed by 20 records, followed by 20, followed by 20, followed by 20. Now, first 20 records, I'm going to use for training. Second 20 records, I'm using for training. Third 20 records, I'm using for training. And fourth 20 records also, I'm using for training. Means how many records I'm using for training? 80 records I'm using for training. And last one I'm using for testing. And I got some accuracy. Some accuracy is equal to 70% I have got. Now this time, one more time, same 5 parts I will divide. But instead of this one for test, this I will use for the test. I'll change the data for test. Training I will change. Training I am changing, testing also I am changing. This is I'm using training. Now again 80% I'm using for training, but different records. And I'm testing on a different data. Now I have got the accuracy is equal to 72%. Now again, I'm dividing the data into 5. This time this part is used for testing, and remaining 4 of them are used for training purpose. Again, I'm using 80% for training purpose, 20% for testing purpose. This time I have got the accuracy of 75%. Next time I'll use the fourth one. Fourth one is, this is used for testing purpose. And fifth one, this is used for the testing purpose. Like this, every part is used for training, every part is used for testing. The entire data was divided into 5 parts, and every part is used for training and testing. Now, every part I have used for training and every part I have used for testing, and I have got a different accuracies. Now, what I'm going to do, which is having the maximum accuracy, I will not consider like that. I will take the average accuracy. What is the average? This is called as average of each part accuracies. Average is called as cross validation score. This is called as cross validation score. Cross validation means every time you are changing the data and you are validating. Cross means changing. Validating means every time calculating the score, accuracy score. So every time you are changing the data and you are calculating the accuracy, and from that you are finally predicting the average value. Now, sir, why you have divided the entire data into 5 only? You can divide into 4 now. You can divide into 3 now. You can divide into 2 only now. You can ask that question. So if I divide for 5, now 4 parts I am using for training means 80% of the data I'm using. If, for example, I have divided the entire data into 4 parts only. Assume I have divided into 4. Now in that 3 parts I'm using for training. Now how much percentage of data I'm using for training? 75%. If I divide the entire data into 3 parts, if I divide the entire data into 3 parts only, out of which 2 parts I'm using for training purpose, 1 part is for testing purpose. Now in this case, what is the train size? 67%, and remaining 33% is for the test. So I want 80% for my training. For 80% of training, what is the CV I have to select then? That is the thing which we are selecting. So I'm going to divide the entire data into 5 parts. Each part, 5 parts. 5 parts. Part is called as, technically in machine learning, it is called as fold. Fold. Fold means nothing but part. Technical word is called as fold. Okay. Meaning is part only. In machine learning, it is called as fold. Fold means 5 folds. 5 folds means 5 parts. Dividing into 5 parts. Is that clear, guys? So by using the cross validation, by using the train test split, and by using with respect to evaluation, by using these 3, I'm going to check whether my model is a good one or a bad one. In that way, we are going to work. Is that clear? Got the point? So that is introduction to machine learning. And from Monday, we'll start with the 1 by 1. All the projects with respect to first one is regression, followed by classification, followed by clustering, and followed by association rules and recommendation engines, like that. Everything 1 by 1. Okay. So Monday's class will be a regression project. First project will be on the regression and how to load the data, how to extract the things, and how to evaluate everything, including the train test split. I'll show you. Cross validation, I will show you. Evaluation, I will show you. How to select your model is a good one or a bad one, I'll show you. And after that, how you have to submit your answer to the seniors also, I will show you. Finally, whatever the work you have done, you have to submit. Submit means not the Jupyter notebook. We are not going to submit the Jupyter notebook. Something we are going to submit. What is that? I'll show you. Everything we are going to discuss end to end, complete end to end. Right? Is that clear? If you have any questions, you can ask. Just it is a basic introduction. Whatever we have done. From Monday, we'll start the actual things. Tomorrow is Saturday. Tomorrow there is no class. Only we are having the test. Same time, 4 o'clock. Right? Done. Syllabus will be up to today. Whatever we have completed till today. Right? Basic machine learning we have completed means only basic machine learning questions only will be there. What is machine learning? What is the difference between supervised versus unsupervised? What is the difference between labeled versus unlabeled data? Only based on these questions will be there. Example. I'm saying example, right? So complete inference statistics, descriptive statistics, majorly more number of questions will be. I'm giving the hint or whatever you want, you feel it. The more number of questions will be from data cleaning and data wrangling. If one is good at data cleaning and data wrangling, he is a very good data scientist. In the industry, okay, what generally the students will think means machine learning project means more work will be on the machine learning on. But actual fact is machine learning work is just 20% of the time. 80% of the time is non-machine learning only. That is EDA, data cleaning and data wrangling is 80%. Machine learning is 20% of time. That is the reality. Right? Is that clear, guys? Done. So please, sir, classes, we are having Python classes are also. Python class, Keviros sir is having Saturday. I think Saturday sir is not having class, right? Only Monday to Friday or Saturday also? Saturday also is there, huh? Oh, then what we have to do? What is the other time you are interested, guys? From morning 9 to evening 4. Choice is yours. Bhavani Shankar, you only type one, which is the best time for you. Just type. We'll go with the voting. If everyone are okay, miss, we'll go with that. If everyone are not okay, miss, you have to change yourself. We can't do anything. Morning 10 is okay. Tomorrow morning 10. How many are not okay? Raise your hands, please. Not okay. Sorry, Bhavani Shankar, voting failed. Many students has raised the hand. Okay, just guys, try to work tomorrow at 4. Okay, tomorrow evening 4. That is only the best time for the evening batch students. For morning batch students, they will come for their timings. For evening batch, because we will be fixed with morning schedule. Okay, so let us go with 4 only. Okay, Bhavani Shankar, for you, after the class, I'm going to upload the question paper in the drive, right? You take the test from your end. That is the only solution for this. Okay, I can't say that don't attend the K-Ross class, right? Just attend that one also, because that is also important. Right? Done, guys. So tomorrow exam will be from 4 to 5:30. Focus on the data cleaning and data wrangling concepts, not the code. Code is also important at the same time. That is also important. Coding is important for the real life. For interview purpose, concept is important. They'll ask what is meant by standards. What is the difference between standardization versus normalization? One of the guarantee question in the data wrangling. In the data wrangling, what is the difference between standardization versus normalization? Of course, in the tomorrow's question paper, this question should be there. 100% it will be there. I have leaked one of the question also. Right? Like this, we'll have the multiple questions which are going to be asked in the interview. In the interview room, what they are going to ask, that questions I'm going to ask in the test. Right, guys? Yes, that is the reason we'll have not get the 100% accuracy. Outside factors are also there. If outside factors are constant, it is not going to impact on outside, then we can easily predict. Next, Abhishek. Sir, my cousin is doing 1.5 years masters in data science. What is the difference? He's having money, you are not having the money. That is the difference. He is having the full of money to do the masters and interest towards to going to US or MS in that. Right? To be a data scientist, nothing. Because in the real life, we are going to work as the same. Whether you complete MS also, we have to do the same project. Whether we do the PhD also, we have to do the same project. Whether we do BSc also, we have to do the same project. Right? More knowledge is there, miss, automatically the salary will be more because they are going to use you in the multiple ways now. Is that clear? Done.